All right, so let's take a look here at this assignment for the week. It says let theta be the angle in standard position whose terminal side contains a given point, then compute cosine, theta, and sine. To say standard position, what they're kind of talking about here, have this graph. Think about it as quadrant 1, quadrant 3, quadrant 4. Okay, don't be scared. All they kind of say here, when you have a point like this, all they're kind of saying x value and so x and y value. Okay, and it says here -1, negative. X is -1, y is -3. Okay, so you have a triangle that looks x is 1. Think about geometry where it's actually, yeah, it says like negative. Really, it's a distance. -3. Yeah, it's a negative. But that's all they kind of mean. So, we have a triangle that looks like this. Okay. I'm going to turn that around. So if I kind of like flip that around, this, that one's on this side, bottom, 3 there. Okay. Figure that out right? Okay, so the hypotenuse is this piece. We're missing this hypotenuse. Got to figure that out. How do we figure out the hypotenuse? Well, we can a squared plus b squared. So there's those calculators I posted before. I talked to you guys about the calculators that are the Pythagorean calculators. Feel free to use that. Okay, if you're not comfortable with the a squared plus b squared, it's c squared. I'm going to go ahead and do mine. Once again, I'm just going to use the positives for right now. Okay, I'm just going to say 1 squared plus 3 squared. That's going to equal c squared. I don't know what that is. At this point, you could go to the calculator on just search Pythagorean theorem calculator if you don't remember, but if you go to week 9 list, or I'll try to make sure I put it in. When I do this, 1 times 1 is 1, plus 3 times 3, which is 9. So what I get here is 1 plus 9, which is 10. And 10 equals some numbers squared. We haven't really gone over this kind of stuff, right, as far as the advanced details on this, but I did show you guys that we got to think of what number times what number equals 10. 3 times 3 is 9, and 4 times 4 equals 16. Some number between 3 and 4. It's going to be some decimal, sort of like pi, just forever we call it a rational number. So what they say is if you take the square root of both sides, it gets rid of the squared. We don't know what that number is, and it's somewhere between 3 and 4. It's some decimal. In fact, it's just we call the square root of 2. We're not going to simplify that. So what that means is the hypotenuse, that answer right there. Okay. Now, sometimes it can simplify, and we're not going to go into that today, but this can simplify sometimes. So, sine theta, cosine theta. Remember that the sine is like SOHCAHTOA. Okay. Sine is opposite divided by hypotenuse. Okay, it's like sine is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. And tangent is opposite divided by adjacent. So sine is the opposite side divided by hypotenuse. So the angle that they're talking about is the angle right here. Okay, the angle is always this angle right there. So between 1 and the hypotenuse, that's the angle right here. So if this is the angle, this is the opposite, and that's the adjacent. Adjacent's always away from the. So my sine, which is opposite divided by hypotenuse, will be 3 over radical 10. But we're going to use the negative like they told us over here. One more time. 3 is the opposite side, but 3 they said was the negative because it kind of works out here. We're going to say is a -3 divided by the square root. Okay. Now the cosine is adjacent divided by hypotenuse, 1 divided by radical 10, but we're going to call it a -1 divided by radical 10. Yeah. Okay. All right, that's problem number 1 out of the way. Good times, right? Let's look at number 2 and let's see that example. Find all 6 trigonometric functions of theta if given the point on the terminal side of theta. So kind of the same exact thing, right? We've got some sort of graph here. We've got quadrants. Okay. Remember, right, it's negative. So when it says negative 12, 5, that means our x is negative 12 and our y equals 5. So x is negative 12. So way over here is negative 12 and y is a positive 5. So somewhere like this. So we can create a triangle that looks like that. Okay. Theta is always going to be in the middle there. So this x is negative 12, y is 5. Remember, this is kind of like a, not only a fake negative 12, but this means that's in this direction. Okay, but the measurement is 12. So if I copy this down, theta here, 12 here, 5 here, oh, yeah, 5 there, right angle there. If you remember those Pythagorean triples, this should be a 13. That was a 5 squared plus 12 squared always equals 13 squared. Do the Pythagorean theorem again. You do the Pythagorean theorem calculator. But if you remember your Pythagorean triples or go through your notes for Pythagorean triples, this will come up. Okay, 25 plus 1 4 equals 100. Every single. Cool. Now remember, it's going to be a negative here when we calculate this. Now the hypotenuse here, the way it's going to work out, we'll just leave it positive for right now. Let's take a look at because what's going to happen. Take a look at the sine theta, opposite adjacent hypotenuse. Okay, so sine, remember SOHCAHTOA, opposite divided by hypotenuse. Opposite is 5 divided by hypotenuse of 5 divided by 13. Cosine, adjacent divided by hypotenuse, so negative 12 divided by 13. Tangent, opposite divided by adjacent, so 5 divided by negative 12. Okay, and then cotangent. So they kind of mix this up, which kind of stinks. Cotangent, let's make a little note here, is the opposite of tangent. So instead of saying opposite divided by adjacent, it's going to be adjacent over hypotenuse. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Cotangent is the opposite of tangent. It's upside down. We call it the reciprocal. So adjacent and hypotenuse. Adjacent and opposite. All right, it's this one upside down. So instead of saying 5 over negative 12, we can say negative 12 over 5. That's it. Secant is the opposite of cosine, or the reciprocal of cosine. The cosine was a over h. We're going to say h over a. So instead of saying negative 12 over 13, we'll just flip that upside down. 13 over negative 12. And then cosecant was the reciprocal, right, the upside down of sine. Sine's opposite over hypotenuse, so hypotenuse over opposite. That would be, instead of 5 over 13, that'll be 13. Cool. Fun. Got all of our negatives correct. Negative, negative, negative. Cool. All right. Going. Number 3 is very similar. This time it says 4 and. So, about this. 1, 2, 3, 4. It says 4 and 2. So positive 4 would be like this. Positive 2 would be like that. Triangle right there. Remember, when they kind of say a point like that, you want to kind of draw like an arrow. That's kind of my suggestion, right? Draw like an arrow. And then the right angle is always going to be on the x-axis. Always going to be somewhere on this axis. You got to kind of imagine a big circle. Whenever we make like a triangle there, it's always going to be something like, however you make your triangle, it's going to be something along yeah, imagine like some imaginary circle on that, and you're making a triangle within there. Terminal side, sorry, not terminal side. I'm blanking right now, but the terminal side is your hypotenuse. Okay, always going to be that inside angle. theta. Always be on the okay. All right. So here we go. It says positive 4, positive 2. All right. That's it. So it's like this. It's like this. 2 and 4. Okay. Notice what's going on here every single time. X value is like your left and right measurement. Okay. Y value is always your up and down. It's always what happens here. So this one's not going to be a Pythagorean triple. So a squared plus b squared is c squared. So let's say 4 squared plus 2 squared equals c squared. Remember, your hypotenuse is always c, and we always and these values are going to be your legs, your left and right and up and down leg. Okay. So 4 squared is 4 times 4, which is 16. 2 squared is 2 times 2, which is 4 squared. That's going to equal 20 squared. So the square root of c squared equals the square root of 20. C, so the square root of 20 is, there's no square root of 20, right? Think of your perfect squares. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. 1, 4. 3 is 9, 4 times 16, 5 times 5 is 25. So you notice between 4 times 4, which is 16, 5 times 5, which is 25, exists some number in the middle there. 4.5 times 4.5, something around there, okay, would exist square root of 20. Once again, it's going to be a decimal like pi that just goes on forever. You got to kind of imagine what that might be. Now, square root of 20 does actually simplify, okay? I'm sure if you guys do your Pythagorean calculator, you'll see it work out, okay? But the square root of 20 is like the square root of 4 times the square root of 5. Properties of square root. No, square root of 4 is 2 times square root of 5. So I highly recommend, please, pretty please, go to a Pythagorean theorem calculator and just plug that number in, okay, and get that number. That is our hypotenuse. Okay. So they want all 4 things again. Remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cotangent, so they have these flipped upside down. Usually I like to see a cosecant. This is how they wrote it. Cotangent is the opposite of tangent, so adjacent over opposite. Secant is the opposite of cosine, so hypotenuse over adjacent. Cosecant is the opposite of sine, so it's going to be hypotenuse over opposite. So my angle's right here. Opposites over here. My adjacent there, and that's my hypotenuse. So the sine, my sine is going to be opposite over hypotenuse. 2 over 2 radical 5. Leave it like that. As far as simplifying it, I'm not going to simplify it more. These will simplify at times. Cosine will be adjacent over hypotenuse, so adjacent over hypotenuse will be 4 over 2 radical 5. Tangent will be 2 over 4. Cotangent 4 over 2. Yeah, just flip these upside down. Hypotenuse over adjacent would be radical 5 over 4, and cosecant radical 5 over 2. All right, let's try these next. So this says indicate the 2 quadrants that could terminate in if cosine theta equals 3 radical 5. So the cosine of theta equals 3 over 5. Remember, the cosine of theta equals adjacent over the hypotenuse. So whenever you see something like this, what they're asking you is, you've got quadrants 1, 2, 3, and 4. So this would look potentially right like adjacent over hypotenuse. So you might, at a basic level, we know it's going to be up there. So where else is the 3 positive and the hypotenuse positive? That's going to be that guy down there. So it looks like it's going to be 1 and 4. Okay, because if it flipped over here, then the adjacent, this piece here would be on the left side, the negative. I think it's going to be 1. Do it. Okay. So if they had a negative here, negative cosine, then it would be All right, so indicate the quadrant which the terminal side of theta must lie in order that sine theta is negative and cosine theta is positive. Ooh, that's a great question. Okay, so for my question says sine theta is negative. Sine theta equals a negative opposite over hypotenuse, but they're saying the cosine theta is a positive adjacent over. So remember, we know that the cosine positive was up here, but the sine's negative, and this is all positive, and it's all positive up. So we know it's not this one, but the other option was down here in 4. Remember that the angle is here, so the adjacent here is positive, but the negative is the y value. That would be a negative down. So I'm going to go ahead and say it's going to be quadrant 4. All right. That's how we work it out. It's very difficult. We'll keep battling this next week. All right. Hope this helps you guys out. Feel free to kind of slow this down and review each question. Go slow. Email me if you got questions, but we will keep working on this next. All right, guys. I'll see you in class.